Good morning, everybody. Welcome to wonderful Monday morning of Chem 1211 with your host, me, Dr. White. First of all, let me wish all of you who celebrate Rosh Hashanah a happy new year. And hopefully you'll have a happy and healthy new year. All right, let's get going. First of all, some announcements. And let me go to Blackboard. And thumbs up, people. Do you see Blackboard on your screen right now? New office hours. Thank you, Rachel. I'm probably pronouncing it wrong. You'll have to correct me. But anyways, I have new office hours. I decided to change them to give more people opportunity. If you need help, come to my office hours. Starting this week, my office hours are now Tuesdays and Wednesdays from 6 to 7 p.m. Again, new office hours starting this week are Tuesdays and Wednesdays from 6 to 7:15 in the evening p.m. And you use the same Zoom login. The only thing that's changed is the day, no Monday anymore. Now that's been switched to Tuesday, and Tuesday and Wednesday will be from 6 p.m. to 7 p.m., 7:15 p.m. And if you have any questions, remember in my class, in my world, there's no such thing as a dumb question. Stop by and ask for help. All right, another thing I want to talk about, because of the changes I've made in my syllabus, and let me do this. Let me go to student view in Blackboard. If you click on my grades, well, actually your grades, but it says my grades, you'll see I've changed this. Where I used to have tests and a final, I now have the various quizzes and test one. Now, if you notice after test one, I have quizzes or quizzes in test number one total. And as I mentioned last week, changing my syllabus, the first tea break, changing my syllabus, the way it's handled is you'll have 6 quizzes and 1 test, and I'll take either the top 4 quizzes in test 1 or all 6 quizzes, no test 1, and that will be your quizzes or quizzes test total. So that's how that's calculated. We'll have test 2, the final exam, and your labs. And one thing, where it says the different labs and the names, I don't recopy it. I put the scores in lab 1, 2, 3, and 4. And later today or tomorrow morning, the lab you handed in last week, I've already graded. I just haven't put the points in Blackboard yet. They're in my grade book, but not Blackboard. Let me do this. Don't need that anymore. All right, as you know, last week I gave quiz 1 and 2. In the future, we'll only have 1 quiz in a week. Unfortunately, COD's Outlook doesn't work well with mail merge, so I had to cut and paste your individual scores. The pretty table I had in Word didn't get copied over to Outlook, but it still looked good enough. You should be able to do that. Now, I'm going to be going through quiz 1, quiz 2 answers, but I'll do it really quick. Normally I don't, but most of you did really well on quiz 1 and 2, which makes me feel very happy. It was really nice that all of you did well. All right, what I'd like to do now is go through we're done with the quizzes. Tea break. Now, a question I would have is, well, we've taken 2 quizzes. What grade am I getting in your class? Now, I'm assuming you've handed in all the labs. Usually labs help keep your grade the same or rise, make it go higher if you've handed in all the labs. But for now, there's still a ton of points. I don't know about a ton, but a lot of points left to go. However, if you need a feel for it, add your quiz 1 and 2 together, and you'll get a number. Hopefully you do. And if that number is 90 and above, right now you're getting an A in my class. If that number is 80 to 89, B, 70, 79, C, just look at my syllabus, 60, 69, D, nobody was down there. Like I said, it makes me happy to see students succeed. I'm not happy when students don't succeed. So please study hard so you'll succeed. And I think most of you, the average on quiz 1 and 2 combined, or each quiz, was very close to 48 or 49. I mean, it was really high. However, think about when I normally teach face-to-face, Chem 1211, I've done it a number of times, because they changed things. I had to give quizzes and only 2 tests. My quiz 1 and 2 are like my test number 1 when I used to teach face-to-face. And usually the average is super high, just like you did. So you're in a good spot. But it's time for me to issue a warning. Warning, warning. My new test number 1, which used to be test number 2, but now test number 1, coming up soon in a week, about 2.5 weeks, I think. I'll have to look it up. You'll have to take on campus at the test center. You'll have the whole week to do it. However, listen, test number 1, the old test number 2, is usually the lowest average of the semester. It's usually the hardest test for students. But I've had classes where that's not true. So if you keep on doing the problem sets and study, you'll do good and not be, you won't get a low test score. However, in the past, like I said, that test has always been the lowest average. And I've had classes, hope you won't, have averages on the test out of 100 points, 70. Oh. But I've also had classes, like a couple summers ago, I had a super class, and I hope you're a super class, where the average was, I think, 91 out of 100. And that makes me feel happy. So study. All right, I promise today I go through problem set 9A and 9B, or part 1 or 2. So I better keep my promise. But first, let me close some things. All right, let's make this a little smaller. Everybody see chapter 9, part 1, practice problems on your screen. Uh-oh. Thank you. Thank you. All right. One of the things I need to do is open something else up. Now, I haven't changed the name. I'll have to get in there. All right, on your screen right now, you should see important information test 2. This will actually be test 1 that I'll have to change on Blackboard today or tomorrow. But you'll be given the name and number of shells of the electron shells and the number of electrons in the name of each subshell. Remember, at the top is lowest energy. When you go down, higher energy. So let's look at this practice problem. And it says, write the electron configuration for. And remember, electron configuration, and let's go back to important information, which will be named. I'll have to add for that. I thought I had it here. But I'll have here electron configuration. Remember, numbers and letters. So how do you do this? Well, we look at the electron configuration. Well, first of all, you need to know how many electrons does nitrogen have. And if we go to periodic table, the the atomic number is 7. So we have 7 electrons. What's the first shell? 1. How many subshells does it have? 1. And that is S. And the maximum number of electrons in S is 2 electrons. Well, I put it there, so that's 1s2. Remember, a subshell name is a number and a letter. A subshell name is a number and a letter. Well, shell 1 only has 1 subshell, 1s. It can take maximum 2 electrons. We've done that. So now we have to go to shell number 2. And shell 2 has 2 subshells, 2s and 2p. 2s, I can put maximum 2 electrons, 2p, 6. So I put 2 electrons in 2s. It's filled up. I now go to 2p. 2 plus 2 is 4. I only have 3 left. 7 minus 4, that's 3. I can put up to 6, but if you notice here, I only need 3. Now, if we look at magnesium, oops, the number 1 fell off here. Sorry, this is a PDF file, so I can't write it in right now. But anyways, here we have 12 electrons, fill the first subshell, the first shell, 1s with 2 electrons. We've now filled 1 up. We have to go to 2. 2 has 2 subshells, S and 2s and 2p. 2s can take 2 electrons, 2p, 6. I do that. 2 plus 2 is 4, plus 6 is 10. This should be 3s2. I do that. I now have 10 electrons. 12 minus 10 equals 2. Shell 2 has only 2 subshells, 2s and 2p. I filled it up. I have to go to the next shell, which is 3. The first subshell, 3s, and I put in, and this is the correct answer. This 2 fell off somewhere. You happen to see my two floating around, send it back. Oh, my goodness. It's awful humor. Anna, is that from, all right, I'll have to look at that channel and see if it's better. Let me do one thing. Thank you for that heads up. I'll take a look at it later on. Now, one of the things I don't have here, and I'll have to make some, is the orbital diagram. And I'll do that, and I'll do that tomorrow. All right, what's the valence electrons? And that is, you should know, the outermost electrons of an atom. And how do we find that? We look at our favorite periodic table. If you notice right here, how many valence electrons does hydrogen, carbon, oxygen, nitrogen, and iodine have? Well, hydrogen, you look on top, 1, carbon 4, nitrogen 5, oxygen 6, iodine 7, and if we look at neon or any of those, it's 8. So the number of valence electrons, the outermost electrons, are found at the top of this periodic table. Now, this is the one you should be using. And when you take my test number 1, coming up soon at COD at the testing center, you will be given a copy of this periodic table. It won't be green because I have these made up. They have about 100 of them, and I give them out during a test when we're face to face. And then I ask students hand them back in so I can recycle them. And I do. And that's the end of practice problem part 1. Let's move on to practice problem part 2 for chapter 9. And again, you should know how to do this. Now, what is a covalent bond? And you should know that's pairs of sharing pairs of electrons between two atoms. By the way, thumbs up, people. Do you see chapter 9, part 2 on your screen? Thank you. All right. I don't have here, but I should have had, what's an ionic bond? And you should know an ionic bond is a transfer of one or more electrons from one atom or group of atom to another atom or group of atom. All right, here, draw the Lewis structures for the following. How do we do that? Well, you find a number of valence electrons. And let's look at water. Hydrogen has 1 valence electron, oxygen 6 valence electrons. Each hydrogen has 1. Remember, you put 1 on one side before doubling up. Well, this hydrogen says this oxygen, I've got a valence electron. You've got a valence electron. Let's share. Now, the non-bonding electrons come along for the ride. Then this side says, I have 1, you have 1. let's share. And they do. And that's how you do it. Now, if we were to look at B, the only way you can make this work is with nitrogen in the center. Now, an important thing, and let me rewrite this on my whiteboard. That's not my whiteboard. That is. Remember, this is called ammonium trichloride. Nitrogen, 5 valence electrons. Chlorine, 7 valence. I know these like I know my own name, which I do know. And the only way you'll get it to work is like this. Now, remember, all atoms gain, lose, or share electrons in covalent. They share, so they have 8 valence electrons in octet. And here, notice this chlorine has, you can't see it, there was a dot there, 8. Same thing here, 8, and the last chlorine has 8. Now, if we look at nitrogen, you can't see the one I just covered up, it has 8. Now, up here, water has its octet, while hydrogen's octet is 2 valence electrons. That's the one exception, its octet is 2. Now, let me remind you, so much for straight lines. Oh, that was pretty straight. All right, you should know the covalent bonds, their name and how many pairs of electrons are being shared. Single bond, 1 pair. Remember, a pair means 2 electrons. So single bond, 1 pair. Double bond, 2 pair. Triple bond, 3 pair. How do you like these special effects? I told you it's awful humor Monday. Anyways, you should know single bond, 1 pair of electrons being shared, double bond, 2 pair, triple bond, 3 pair. And if we look at HCN, hydrogen cyanide, here's the structure. Let's go through it. How do you draw the Lewis structure? For this hydrogen cyanide. You have 1 hydrogen, remember Lewis structure, valence electrons. I have a hydrogen, a carbon, and nitrogen. Hydrogen says to carbon, oh, you have one, I have one, unpaired valence electron, let's share. Well, now carbon says, I have 3 unshared valence electrons. Nitrogen, you have 3, let's share. And they do. And the non-bonding electrons come along for the ride. And in hydrogen cyanide, HCN, this is a single bond, and you should be able to identify that. And this is how many pairs? 1, 2, 3. Remember, pair means 2. And up here it says name, triple bond, 3 pairs, and that's a triple bond. Now let's look at E. NaOH is sodium hydroxide. How do we do this? There's the answer, but how do you do that? Good question, so I better do it. Draw the Lewis structure for sodium hydroxide. Sodium has 1 valence electron, oxygen 6 valence electrons, hydrogen 1 valence electron. However, all alkali metal, all alkaline earth metals always form an ion. They are never in a covalent bond. So how do we do this? Well, what ion does sodium have? And we did that before. Nearest noble gas is neon. It will have 11 protons, but 10 electrons. Sodium will have a plus charge. It gives up 1 electron. Therefore, I can immediately write this. Because sodium, lithium, and potassium always form a +1 cation. Now, oxygen has 6 valence electrons, hydrogen has 1. They say, let's share. However, if you look here, oxygen only has 7 valence electrons. That's not good. It wants 8. Well, where did this valence electron go to form this cation? It goes right here. Now, this will have an extra electron, so we'll put it minus charge. So in this molecule, we have 2 different types of chemical bonds. Between the hydrogen oxygen is a single covalent bond. Between the sodium, and this is called hydroxide, OH minus hydroxide, there's an ionic bond. And that's what there is in that molecule. If I look at the clock, it's time for us to take a 5-minute break, come back at 9:55, and we'll continue. I'll see you in 5 minutes. Time to get going. I saw one of your colleagues had a question about tomorrow's lab. If you have if it's a quick question, why don't you ask it now? Or do you want, if you want to do it in private, see me right after class?
Okay, I'll do it in private if you don't mind.
I don't mind. That's why I gave you the option.
Okay, thank you.
You're welcome. All right, let's get back to work. All right, let's move on. By the way, here's carbon dioxide. If you notice, what type of bond is between oxygen and carbon? A double bond. And there are two double bonds. Now, as I said earlier, not later, earlier, bad Dr. White, what are the three types of bonds, covalent bonds? And you should know the names and how many pair of electrons each covalent bond has. Single bond, one pair, double bond, two pair, triple bond, three pair. Now, we talked about hydrogen bonding, which is very important. You should be able to give an example of a molecule that can hydrogen bond. Now, the easiest one to remember, water. But ammonia, NH3, will hydrogen bond. Alcohols, such as the ethanol that's in gasoline, or ethanol, not that I'm implying in any way, that's the tiny little molecule that's in beer, wine, and hard spirits. My favorite vodka, Grey Goose Absolute, or what's really a good vodka. Shh, don't tell anybody. Remember, you got to be of age to drink or buy alcohol. If you go to Costco, they're French. The more expensive the two vodkas they sell. Don't buy the American, but it's good. The French one, it's got the red at the bottom of the bottle. You know, red like this. Oh, by the way, if you haven't noticed, summer is over. Last week, I finally broke down and turned on little slide switch, turned on my heat, turned it up so it'd burn out any dust or anything that's on the burners. I always do that the first time, let it run a while. Hasn't really kicked in, but it's on. My air conditioner's off. If you notice, I'm not wearing a short sleeve shirt, and I've changed in my closets. I moved to the front position my long sleeve shirts and tops, and moved my short sleeve to the back of my closet. It's fall. Oh, I just thought something sad. When I teach face-to-face on Halloween, if I have a class, which I have, I always bring candy for my students. And by the way, I go, just like I teach by my golden rule of teaching, I don't do to my students what I wouldn't do myself. I have my golden rule of Halloween candy. And I only give candy to my students and also people who come to my front door, little kids, a candy that I really like. I don't give that garbage they sell. I do give the good ones, Kit Kats. That's one of my favorite. All right, back to work. So you should know water will hydrogen bond, ammonia, alcohols, and HF. It's called hydrofluoric acid, and that will hydrogen bond. All right, any questions about the material on those two problem sets? Looking down at my chat here. Well, in that case, let me close this.
I just have one more question. Is everything what we did so far will be on the test number 2, right?
Right now, we're
Okay.
going over. So, wait,
I'm sorry, one.
Guess what? I'm confused too. You got me. All right. Anyways, we'll have two tests. Test number one, this material will be on test number one. And then in coming weeks, when we're doing stuff, I'll tell you which quiz the material is going to be on. Now, normally I finish like more than normally, like almost always, I finish about a week before the material that will be on the next test or quiz. That gives you plenty of time to do the practice problems and gives me plenty of time to go through the practice problems with you. And thank you for your question. All questions are good questions. All right. Sorry about the delay. I had to open some stuff. All right, we're talking about the mole. And this is important information that I'll be, renumbering. That's test number one, important information. My old test number two, confusing, yeah. But anyways, you should know 1 mole of an element equals Avogadro's number, 6.02 times 10 to the 23rd atoms of that element. 1 mole of a compound equals Avogadro's number of molecules of that compound. In the past, I used to make what I just highlighted. Students have to memorize that. And then a couple of years ago, I came to the decision based on an interesting discussion I had with another faculty member in chemistry at COD. Do I test your memory or and your knowledge of chemistry, or should I just test your knowledge of chemistry? And I decided on the later, test your knowledge of chemistry, which is why you don't have to memorize it, but you do have to know how to use that. So it's mole practice time. Let's do some more. I was going to write out something in cursive, and I forgot. All right. Question is, how many molecules NaF, sodium fluoride, are 7.112 moles of sodium fluoride? By the way, sodium fluoride is put into your toothpaste. It's also put into our water to help promote healthy teeth and gums, and it does. So what are we being asked to find? How many molecules of sodium fluoride are there? What are we given? We're given how many moles of sodium fluoride. So how do we proceed? Well, if you look at this, once you've done this, you don't have to read the problem. There's only one number we have to start with. what units do we want our answer to be in? Well, we figured that out. Molecules, sodium fluoride. So how do we get from here to here? Well, if there's some ratio that I can convert moles of sodium fluoride to molecules, here's my ratio. And it's time to use your good buddy, your good friend, unit analysis. And for many decades, I shouldn't have said that, but it's true. It's been my good buddy and my good friend. And for a long time now, students have found it's their good buddy and their good friend, my students. How does it work? Whatever you're trying to get to goes on top of the ratio. The units, whatever you're trying to get rid of goes underneath. Remember, anything divided by itself equals number one, meaning it cancels out, which is why we put the units that we want to get rid of underneath that ratio. So I'll write that in there. I'll write this here. And where do we get these numbers? From important information, the new test number 1. And 1 mole of a compound, and sodium fluoride is a compound, equals 6.02 times 10 to the 23rd molecules of that compound. So remember, whenever we have two things equal each other, there's two ratios I can always have. They're not equal, they're separate. One side over the other and vice versa. And here we have 1 mole compound equals Avogadro's number. You should know 6.02 times 10 to the 23rd is Avogadro's number of molecules of that compound. Therefore, up here, molecules from this statement, 1 mole of a compound, and sodium fluoride is a compound, equals 6.02 times 10 to the 23rd. Why can we do that? Because of this. Well, before I pick up my calculator, which happens to be handy, notice moles divided by moles cancel out. I'm left with what units? Molecules of sodium fluoride. And you should always do that. And now I can happily, I told you it was obnoxious, turn on my calculator, clear it, 7.112 times 6.0, and then to get double exponential, I'm pointing at my screen, the 23, I'll do second key, double E, 23 equals, and my calculator gives me this number. And on test number 1, like your quizzes, it'll say, please use proper significant figures for all calculated answers. 7.112 is 4 significant figures. The number we use in this class for Avogadro's number, 6.02, is 3 significant figures. 1 is part of the definition. It's an exact number, which does not play a role in a calculation. Since it's a multiplication division, the number you get should be the same number of significant figures as the number you multiply or divide that has the fewest significant figures, but you ignore exact numbers. So the lowest number is 3. We have to round this off to 3 significant figures. Keep the 4, keep the 4, keep the 0. That's my 3. Use that to round off. It's 9 or higher. So the correct answer is 4.41 times 10 to the 24th molecules of sodium fluoride. Now, important thing, listen, show your work. What if on your test number 1, you forgot and you made a mistake, instead of putting in 7.112, you put in 7.113. You're going to get the wrong answer. But if you show your work and I can follow it, and if this were a 5-point question and you made a math error, I'd take off 1 point, you get 4. If you don't show your work and you make that math error, you knew what you're doing, you just punch something wrong into here. Do you punch your head calculator? Push. Let's be nice to our calculator. Anyways, well, that was lame. But anyways, then if you did no showing your work, I'd get 0 points. You'd get 0 points. So it always helps to show your work. I see a question. I made a mistake. Uh-oh. Well, I showed my work. Thank you, Anna. That happens once in a while. I forgot to put the 0 in. Let me do it again. And if you remember the first day of class, I said, I make mistakes too. All right, let's get this. Thank you very much, Anna. Let's try this again. If you do the math correctly, Dr. White, you get 4.281424 times 10 to the 24th. See, it is important to show your work. I would have gotten 0 points. So still 3 significant figures. Keep the 4, keep the 2, keep the 1. I mean, keep the 8. Use 1 to round off. And it's 4 or less, you drop that. And this is the correct answer. Did I get it correctly this time, Anna? And everybody else?
Yes, thank you. I just wasn't sure if I did it wrong or you did it wrong.
I did it wrong. This
Thank
is now the correct answer right here. All right. I will say it publicly. Okay, hold on, let me look at Shane. All right, I'm done looking at Shane. All right, let's try another one. And this time, I'm going to give you some time to set it up. We'll do it stepwise. This is called hydrobromic acid. We'll talk at the end of the semester, week 14 or thereabouts, about acids and bases. And the question is 5 points. How many moles HBr are 7.897 times 10 to the 36 molecules of HBr? And we're going to do it stepwise. First step I'm going to ask you to do is write down right there, what are you being asked to find unit-wise, and what are you given? That's all I'm asking you to do right now. And when you've done that, give me a thumbs up. Thank you, Anna. Everybody else, when you're done, give me a thumbs up. Or you can also do the thumbs down emoji or any kind of faces. We'll give everybody time to finish. All right, let's do this. What are you being asked to find? I like to put a question mark, moles of HBr. What are you given? 7.897 times 10 to the 36 molecules HBr. And when you're doing this, be sure to include units, not just numbers. All right, well, we only have this number to start with. What units do we want our answer to be? Well, we figured that out. Now, don't forget to put the units here. Now, if I had a conversion factor, what goes on top unit-wise, what goes underneath? Your turn. I'll give you 20 seconds to figure out what goes on top. This are units, not numbers. 4, 3, 2, 1. I'll give you an extra bonus seconds. I take some water to hydrogen bonds. Wow, look at everybody's name on the screen, except for mine. Everybody else's name ends in the letter first name A. Wow, it is Happy New Year. That's a miracle. All right, how do you determine what goes on top of the ratio and what goes underneath? Use your good buddy, your good friend, unit analysis. And how do you use your good buddy, your good friend? Whatever you're trying to get rid of, get to, goes on top of the ratio, whatever your units you're trying to get to, whatever you're trying to get rid of. I don't want molecules of HBr in my final answer unit-wise. You go there. So now I'll write that down. And where do we find a relationship between moles of a compound and molecules of a compound? Not with me, yes, with me. You look at important information. Test number 1, which I got to change the name today or tomorrow. 1 mole of a compound equals Avogadro's number 6.02 times 10 to the 23rd molecules of that compound. And now, since you know this, I'll rewrite it. What numbers go on top and bottom? Your turn. Hint. When you're done, give me a thumbs up. All right, 2 people done. By the way, if you don't want to do a thumbs up, give me a thumbs up telling me you don't like doing thumbs up. No, I'm just kidding. All right, let's do this. 1 mole of a compound is equal to 6.02 times 10 to the 23rd molecules of a compound. HBr is a compound. Remember, anything divided by itself cancels out because that's number 1. Therefore, molecules of HBr divided by molecules cancel out. We're left with the right units, because we do want in our final answer moles of HBr. And now I can happily pick up my calculator. Keep an eye on me. I made 1 mistake already today. I better be careful. Being careful now. And my calculator gives me the number . Here. And on test number 1, like my quizzes, will say, please use proper significant figures for all calculated answers. And this is a multiplication division. This has 4 significant figures. The 1 is an exact number, not considered in a math operation. And for Avogadro's number, we use 3 significant figures. Which one of these is the lowest number? 3. I'll give you 10 seconds to round this off to 3 significant figures. Go. Time's up. Keep the 1, keep the 3, keep the 1. Those are my 3 significant figures. Use the 1 to round off. That's 4 or less. I'll drop that. And did I get it right this time?
Yes.
Oh, yay for Dr. White. And here's your answer. Now, you don't have to put the units down, but I always do. And that's how you do this. You should practice this. All right, let's get back to our chapter. We've done our practice time. Now, next couple of slides, let's see. This slide I'm going to skip. Essentially, we're not going to, the subscripts for a chemical formula indicate the number of atoms. We've done that. You have 1 mole of a compound that indicates how many moles of an element are present. Guess what? I've been doing chemistry in industry since 1978, and after I got my PhD. Guess what? I've never ever had to use this other than something you won't ever use, and that's very rare even for me. So I'm skipping it. All right. You're welcome, Anna. And that's just the way I teach. If I've never used it, why am I teaching it to you that you're never going to use it? Well, I don't. All right. Now, if I had a dial that I could turn to 10, I've just turned it to 20. I stole that from the movie This is Spinal Tap. But anyways, let's talk about molar mass. This is probably the most important concept I know in all of chemistry. It's up there in the very top. And what does that mean? The element molar mass, and I'll show you a better way to remember this, so your book has it, is the quantity in grams of an element that equals the atomic mass of that element. Molecular molar mass, and I'll show you a better way. You don't have to memorize the slide. I'll never ask this on a test or a quiz. And that's the quantity in grams of the formula mass, formula weight of a molecule equals the formula mass of the molecule. What does that really mean? This, 1 mole of a compound equals the atomic mass in grams or weight. 1 mole of a compound for a compound equals the formula, which I also call molecular weight. In grams. I know of nothing more important in all of chemistry. Well, there are a couple others that are almost equal to this, but this is really important. And if we go to important information, test number 1, I've got to renumber this. Everybody see on the screen highlighted, 1 mole of an element equals the atomic, thank you, Anna, atomic weight of that element. Thank you, Brianna. And everybody else, thank you for coming to class. And for those of you in YouTube land, thank you too. All right, 1 mole of a element equals the atomic weight of that element in grams. 1 mole of a compound equals the molecular weight of that compound in grams. And in case you forgot, I put in important information. The molecular weight of the compound is the sum of all atomic weights in that compound, which we did earlier this chapter. So what does that mean? If we go to our friendly neighborhood periodic table, which I closed, which I'll now open. All right, everybody see the periodic table? For elements, the atomic weight, the number underneath equals 1 mole of an element. Now, on my test 1, quiz 3, 4, 5, 6, and test 2, it will say now underneath your name, please use proper significant figures for all calculated answers. And it will also say, please use 3 significant figures, 3, for all atomic weights. And therefore, 1 mole of hydrogen atoms is 1.01 grams. 1 mole of sodium atoms is 23.0. That's this number rounded off to 3 significant figures. If I have, let's go to the high price neighborhood. 1 mole of gold, the atomic number, the 3 significant figures is 197. So if I want a mole of gold, I need 197 grams of mole. If I needed 1 mole of silver, Ag, the atomic weight to 3 significant figures is 108. So if I wanted a mole of silver, that would be 108 grams. Now, one of the things that students get confused in, they go, oh, I'm confused. How can a mole of, say, silver equals 6.02 times 10 to the 23rd atoms, but a mole of silver equals 100, what was it, 107 grams, I think I just said? Let's find out. Actually, 108 grams, rounding it off to 3 significant figures. Well, how can that be? Well, think about eggs. How many eggs in a dozen? 12. How much does 12 eggs weigh? Well, you'd weigh them. You get a number. I'm going to pick a number just right out of the top of my head. Oh, that was awful. But anyways, let's say 500 grams. So a dozen eggs has 12 eggs, but a dozen eggs weighs 500 grams. So you can have both things true. A dozen is 12 eggs, or a dozen eggs weighs this amount. Well, same thing with atoms and molecules. You can have a mole of how many atoms is silver? 6.02 times 10 to the 23rd. What would it weigh? The 3 significant figures, 107. So again, from important information, test number 1, we have what I highlighted. 1 mole of an element equals the atomic weight of that element in grams, and 1 mole of a compound equals the molecular weight of that compound in grams. And the molecular weight of that compound is the sum of all atomic weights in that compound. And in the past, students would have to memorize this. Good news, you don't. I will give this to you. This information will be on the last, how many pages do I have here? Last 2 pages of test number 1. Remember, you're going to have to take that coming up in the near future at the COD Testing Center, but you will have this on the last 2 pages. So let's continue back to our chapter slides. So 1 mole of a molecule equals the molecular weight in grams. 1 mole, of an element equals the atomic weight in grams. It's practice time. Determine the mass in grams for 1 mole of silver. Well, we did that. you look at the atomic weight. And the three significant figures, if my memory still works, it was 108. But how many moles is 1 mole of water? And I expect you should know that now. This is one of the few compounds I asked you to know the empirical formula. Water is H2O. Well, how do we do that? And I'm going to use the abbreviation MW for molecular weight. 1 mole of a compound equals the molecular weight of that compound in grams. That's what this G is. And the molecular weight of the compound equals the sum of all atomic weights, and I'll use that abbreviation AT period WT, all atomic weights. So if I want to know what does 1 mole of water weigh, how do we do that? Well, it's the sum, it's the molecular weight. What's the molecular weight of water? Two hydrogen, 1 oxygen. That's 2 times the atomic weight of hydrogen, which if we look at our periodic table, it's 1.01 times 1 times the atomic weight of oxygen, the 3 significant figures is 16.0. Do the math, add it up, and we get that number. Now, remember, when you're doing addition, you get the same number of significant figures to the right of the decimal as the number with the fewest significant figures to the right of the decimal. This has 2 significant figures. This has 1. Which is the lowest number? Hopefully I'll pick 1, keep the 0, use the 2 to round off. So for water, 1 mole is 18.0 grams. So remember, the molecular weight of a compound equals 1 mole of that compound. And the molecular weight is the sum of all atomic weights. So if we go back to practice, if we look at the next one is ammonia, NH3, we would have to find 1 mole of ammonia in grams equals the sum of the atomic weights for ammonia and that has 3 hydrogens and 1 nitrogen. Each hydrogen, what's the atomic weight? The 3 significant figures, it's 1.01. Now, if we look at nitrogen, 14.007, the 3 significant figures, keep the 1, keep the 4, keep the 0, use the second 0 to round off, that's 4 or less. I'll drop that and the 7, so that would be 14.0. And remember, the molecular weight This is 1.01. This is 1 times 14.0. I'll do the math. Add it up. Now, again, remember, you have the same number of significant figures to the right of the decimal when you're adding up numbers in your answer as the number that has the fewest significant figures to the right of your decimal. Here's my decimal point. This has 2 significant figures, the 0 and the 3. This has 1, the 0. Remember, all zeros at the end of a number with a decimal are significant, which is the lower number. Hopefully I'll pick 1. Therefore, this should have 1 to the right of the decimal point. This is my 1 I keep. Use this to round off. It's 4 or less. And the correct answer would be 17.0. But I asked how many grams? 1 mole of ammonia, 17.0 grams. Now, if I look at the clock, we only got about a minute and a half left. So I'm going to say, don't forget, tomorrow we're going to do a lab. Tomorrow's lab is due tomorrow. Obviously, the one we did last week is due tomorrow. Not tomorrow's lab is due tomorrow. But anyways, it's New Year's. You know I'm happy. With that, I'm going to say, don't forget, I have new office hours. They're no longer Monday, Wednesday. They are now Tuesday, Wednesday, and they're no longer starting at 5 o'clock. They start at 6 to 7:15 in the evening. With that, I'm going to say goodbye. But if you have any questions, hang around. I won't run away. And with that, I'll say goodbye. Gang gesund. Bye now.